Hello, in this video we're going to derive a contract curve using the Lagrangian. We have two traders with the following utility functions, trader A or person A, and person B's utility function. Between the traders they own 100 units of good X, so 100 equals X subscript A plus X subscript B, and if we want we can solve this for X subscript B. And between the traders they own 50 units of good Y, which implies the following. These last results here, this X subscript B equals this and this Y subscript B equals this, we're going to get to that in a second. We're going to use those results in our next slide. So what we want to do is derive the contract curve. We're going to maximize person A's utility function subject to the constraint, which is going to be person B's utility function. So I'm going to set up the Lagrangian. Here's person A's utility function plus lambda multiplied by the constraint. So what do we have here in the brackets? So we're maximizing person A's utility for a given level of person B's utility minus the following. So where are these results coming in? So in person B's utility function, I'm going to substitute out X subscript B for that result we saw in the first slide. What is X subscript B? Well, it equals 100 minus X subscript A. And then I do a similar thing for Y subscript B. As we saw in the last slide, Y subscript B equals what I have in parentheses here, 50 minus Y subscript A. So we're going to maximize this. We're going to take a partial derivative of the Lagrangian with respect to X subscript A, and we will get this result. Bring down the 1/2 in front, 1/2 minus 1 leaves us with this over here. This lambda is being multiplied through by this minus big term over here, and taking the partial derivative of that, I'll get the following. I'll bring the 1/2 down in front, and then 1/2 minus 1 leaves us with this term raised to the minus 1/2 power. Nothing I have to do with this over here. That just hangs along for the ride. One other thing I have to do is I have to look inside the parentheses here and take the derivative of what's inside parentheses here with respect to X subscript A, and that would be minus 1. But since I have a minus here and then a minus 1 being multiplied through all of this, that's why I have a plus term in front of the lambda. Okay, that's why we lose this minus term, because the partial derivative of what's inside here is minus 1. All right, we do a similar thing for the Y good. Very similar partial derivative. Okay, I won't explain this, but pretty much the same idea. And then one other partial derivative, we will take the partial derivative of the Lagrangian with respect to lambda, and what we'll get back is what's inside parentheses. All these partial derivatives are set equal to 0. The next step, rewriting the first partial derivative, I am going to solve this for lambda. So moving this first chunk of terms here over to the right-hand side, we now have a minus here. The next step here is to realize we got a 1/2 and 1/2 over here, so they cancel. And then the next step, on the left-hand side, I'm just going to divide through by this term, and that will leave us the following on the right-hand side. Likewise, I'll take this term on the left-hand side and I'll divide everything through by it, and that will move this term over here on the right-hand side. Okay, just so following the rules of exponents here. And now I'll do a similar thing for the second partial derivative. We're going to solve this equation here for lambda. So once again, moving this first set of terms over to the right-hand side, we've got the minus. The 1/2s now will cancel. And then on the left-hand side, I'm just going to divide everything through by this first set of terms here, 100 minus X subscript A to the 1/2 power. Doing that, it brings it over to the right-hand side. And then finally, on the left-hand side, I have this 50 minus y subscript a to the minus 1/2 power. Dividing everything through by that, we'll get this 50 minus y subscript a to the 1/2 power to appear on the right-hand side. Our next step is to take these two lambda equations and set them equal to one another. So doing that, first thing I'll recognize are the minus and minus. That will cancel, leaving us with this. The next thing I do here is on the right-hand side, I am going to divide through by 100 minus xa raised to the minus 1/2 power. So that'll disappear on the right-hand side, and then on the left-hand side, that'll simplify to 100 minus x subscript a here. And then the next thing I'll do is I'll take this 50 minus y subscript a to the minus 1/2 power and divide everything through by that. Doing that, the right-hand side will just simplify to 50 minus y subscript a. Rewriting that last result. And so the next step here is I divided everything through by x subscript a to the minus 1/2 power. Doing that, the right-hand side will just get x subscript a. And then finally, I took this y subscript a raised to the minus 1/2 power, and I divided everything through by that term, giving us just y subscript a on the left-hand side. Multiplying both sides through by what's in parentheses, we get this result. This term and this term will cancel, leaving us with this. And simplifying, we get the contract curve. Rewriting it either way. Okay, I hope you found this video helpful.